As a follow-up to that talk, our next speaker is going to be Allie Richardson. She's also from Disney's Animal Kingdom. She'll be speaking on linking environmental monitoring of Partula snail enclosures to population demography. Demography, thank you. Allie is a research associate on the science operations team at Disney's Animal Kingdom. In addition to Partula environmental monitoring, she's involved with a variety of projects, including white rhino activity budgets, collection planning metrics, and blue-crowned laughing thrush breeding behavior. Partula snail work is her first foray into the invertebrate world. Welcome to the club, and welcome, Allie.
Green. Awesome. Hi, everyone. I am Allie, and I will be talking to you about the environmental monitoring that we've been doing on our Partula population at Disney's Animal Kingdom and how we're trying to link that to their population demography. As you may have guessed, there will be some significant overlap between Nick's and my presentations because we do work very closely together in this project. So hopefully it's not too repetitive, but at least you'll go home with twice the message and hopefully remember it that much better. So general overview, once again, Partula snails from the French Polynesian islands of the Pacific. Originally around 120 species before they were decimated by the predatory rosy wolf snail, as Nick mentioned, and now at least specifically on Tahiti and the islands of Tahiti and Moorea, there are only about 12 species that still exist, many of those only existing in human care. So a lot of those are extinct in the wild. That is why conservation efforts are of the utmost importance. There are Partula populations in both the US and Europe as far as I'm aware. I believe about 6 facilities in the US have Partula. We specifically, as Nick mentioned, have Partula nodosa. Those are one of the extinct in the wild species. And so we're really concerned with boosting those numbers, boosting survivorship, and hopefully contributing to conservation efforts to get them reestablished back in Tahiti. So as of our last census at Disney's Animal Kingdom, which was at the end of last month, we had approximately 1,200 Partula snails in our collection. And just to drill down a little bit further, as Nick mentioned, we currently have 3 different groups of Partula snails with 8 to 10 tanks in each group. The population is approximately evenly split among those tanks. You can see red and yellow have 350 individuals, blue has 500. But that is essentially to ensure that they get serviced once every 3 days. They're allowed to go through that wet-dry cycle, and yeah, hopefully bolster their husbandry in that way. So, what are we looking at here? For the foreseeable past of Partulas in our population, we have seen rises and falls in the population as a whole. This is 12 years of census data from Disney's Animal Kingdom. Each of these lines is an individual tank, and you can see that they all kind of go up together, they all kind of go down together in almost a seasonal way that doesn't actually adhere to the seasons of the year. And this is not limited to Disney's Animal Kingdom. We've heard that some other facilities also experience rises and falls like this. So with a snail as threatened as this, where a population crash can really be detrimental, we want to figure out, why is this happening? Are these part of a natural life cycle that the snails happen to go through in their population? Or are there variables that we can actually influence to stop this from happening? We have done previous research that finds it is not a density-dependent issue, so we want to look at other factors. So we chose to look at environmental variables. Is there something in their environment that we can control and make them stop crashing so often and bolster their numbers? So just to reiterate, this was our snail setup when we began the study, moving from the old tanks into the new tanks. As Nick mentioned, we used 2 devices to collect the environmental data. We are looking at 3 total environmental variables. So this device here, the hobo logger, the green one, collects information on light intensity data. And the small silver one is the I button, and that collects data on temperature and humidity. So we have approximately 10 sets of these devices, and we put them in even samples across the 3 groups. So red has 3 device sets, blue has 3 device sets, and yellow has 4 device sets. And we stratified them across the groups to make sure we're not clustering in one area. So for example, yellow would have one here, one there, one here, and one there, so we can get a representation of what the snails in those tanks are experiencing in their daily existence. We also implemented a mortality data collection protocol. So as I mentioned, once a month, the husbandry team will take a census. They'll count each snail in each tank and divide it into age classes. So the age classes for these creatures are newborns, juveniles, subadults, and adults. And so we wanted to get an even closer look at what is influencing these population crashes. So we implemented a daily mortality count, essentially. So whenever the groups are serviced, one each every 3 days, they also tally up how many snails are deceased in the tanks. And we will use this information to hopefully generate a mortality rate from both the census data and the mort count. All right, so just quick refresher. This is how we started. We first started in March of 2023, so we have 15 months worth of data. We started with the 3 groups like this in the room. Then we moved into the new tanks and into the butterfly nets, groups more clustered together. And then more recently, we implemented the fans, still in the butterfly nets, still in the groups, moved the yellow group down so that the fan could be on top. But these are the 3 main changes that we've seen in setup in the 15 months that we've been doing this project. So what have we seen so far with all this data? So this is a graph of the average daily temperature of each of our focal tanks. So each of these colored lines represents one tank, and the colors obviously denote which group it's in, red, yellow, and blue. And then this fun black line is our population count. So we were, I don't want to say lucky enough, but we saw a population decline in the time we had the data going. So we were lucky enough to be able to get the data on what was going on there, but obviously we don't want to see that decline. And we'll be able to see if these data have anything to do with that population decline. So looking at temperature, we don't really think that temperature had an influence on this population decline. You can see in the summer months of last year, right about this time, that it got a lot more variable. The lines spread out a lot more from each other, but we think that's probably due to the AC kicking on a little more and causing more of a temperature gradient throughout the room. You can see once summer was over, it kind of got, more close together again. But across all the 15 months, this is only about a 4°C difference. It did not fluctuate between tanks more than that, and that's about 7°F, which was well within the range for the Partula. So not a ton of huge changes in temperature, so we didn't think it had a huge influence. Humidity, though, was a different story. So as Nick mentioned, we got our new tanks. You can see that noted here and here. Red group got new tanks here, yellow and blue got new tanks here. It's hard to tell because we experienced a period of device malfunction in June and July of last year. That's what that flat line is. But once we got back to normal, you can see that after the new tanks, red group just kind of lost all fluctuation in daily humidity. And then you can also see pretty clearly that the same thing happened to yellow and blue group. The minute it got their new tanks, all fluctuation was lost. You also might notice that this happens to coincide with the very start of the population decline right here. So we do think that there is strong evidence that there's a correlation between these two things, that these snails really do need that fluctuation in humidity for them to thrive. Once we noticed that there was no fluctuation in humidity, we did try to restore that fluctuation, drilled more holes, added different amounts of water, more or less, tried a bunch of different things. And then we brought in the wind tester, and we discovered that there was really no airflow getting inside these butterfly nets to the tanks. So that is when we implemented the fans. You can see red group got their fans right here, and immediately humidity fluctuation was restored, almost immediately. And the same for yellow and blue group there in the middle of May. We do work at a snail's pace, so it is too soon to tell if that will bolster the population if that's what they needed, but you see that little bump, it's going up a little bit. So we do hope that in the census in the next few months will be even more revealing that, they really wanted that humidity fluctuation. We gave it back to them. Hopefully their population will begin to increase. We are also toying with how to get an even amount of airflow to all the tanks as well, because right now only the tanks that are closest to the fan are receiving this fluctuation. So we want to make sure that they can all get the even fluctuation and it's restored to all tanks. And then finally, we have our light intensity data. We don't think that there's currently any strong correlation between this and the population decline that we've seen. The most interesting thing is you can see that red and yellow kind of switched places here when we put the butterfly nets around red group, just because it blocks the light a little bit more. But we don't think that there are any strong indications that this caused that population decline. So we calculated mortality rates from our collected MORT data and our census data, and this is simply a method of equalizing between tanks. So one tank, Nick gave an upper limit, but just say one tank has 100 snails, one tank has 10 snails. The amount of mortalities in each of those tanks aren't comparable until you standardize it for the population size in each tank. So that's all that the mortality rate allows us to do and makes it comparable between tanks with different populations. So you can kind of see that right here we had a peak in all three groups for mortality rate, and it kind of coincided with the start of the decline. We also had a bout of peaks for all groups in October, November, December, where the decline continued. Really high peak in March, but we do know what that was from. That was a fly infestation that got to one of our tanks, unfortunately, so not related to these other environmental variables. But once we do get more data, once we get more census data, once we can correlate that with the mortality rate data, we do hope to get more specific about these correlations to these environmental variables. So mortality rate is one possible dependent variable that we can correlate with the environmental variables. Looking a little more specifically, we also broke it down by age class. And I think this slide is very compelling. You can see that juveniles, subadults, adults, they were doing okay with their populations, more or less stable. Adults kind of dropping off here in recent months. And mortality rates, kind of within the same range. You can see that fly infestation. Kind of within low range, nothing crazy. And then you look at newborns. Very high peaks. Very sharp decline in overall population, where you can see it almost exactly mirrors the overall population decline, the shape of that overall decline. And it's worth noting that all of these three age groups, the max value on the y-axis is 1. The max value on the newborn axis is 1.4, because their mortality rates were much higher scale than the other age classes. So it's clear from these data that newborns are a very sensitive age group to environmental fluctuations, and that's good information for us, because then we can really focus on those as an age class, what they need and what we can do to help make them resilient to other environmental changes like we've seen recently. So we did learn that newborns are a very, very focal age class that we absolutely want to keep our eye on moving forward. And speaking of moving forward, we have a few things we'd like to continue to do. We would still like to keep up with what we've been doing, the data collection of environmental variables, the mortality data, hopefully getting a closer link to those two, especially as we hope our population increases again, so we can get a strong link there. We would love to implement focal follow studies, sort of individually identify animals at different ages and stages in their life to sort of really nail down when they graduate from one age class to the next. There has been research done on it, but sometimes some snails just seem to hang out in an age class for much longer than we think they will. So we'd love to see if there's any environmental variables influencing that. And lastly, we would love to complete a light box study to really sort of zoom in on what light could mean for these creatures. In the literature, there has been work done where light is good for adult fertility and fecundity, but it is bad for newborn survivorship. So if we can get a light box with different light intensities, see which side they prefer to hang out on, see what they choose to do, then maybe we can put that into our husbandry protocols and consider that moving forward if the environment needs to be changed to suit those needs. And that's about it from me. Special thank you to Nick and Jamie for collaborating with me on this project. Thank you to the entire SME team at Disney's Animal Kingdom. And yeah, we want to put the call out to anyone who has Partula in their collections. We would love to see this protocol get implemented in other places. We'd love to help set you guys up with devices and data collection, because the more data we have, the better we can understand what these guys need. And yeah, that's it for me. Thank you.
All right, we've got about 3 minutes.
Where do you project that you'll be releasing these back into the environment if it still has, the predators that will destroy them? What are your plans for that?
So that is entirely on the government of Tahiti. That is completely in their hands, as far as I understand it. I know that they're doing work with predatory exclusion zones as well. It is certainly not a complete or perfect solution, but they're still working on doing it. I don't believe our facility has released any in quite some time, but I do know last year, a few other facilities did send some back to Tahiti that were from human care snails here in the United States. Oh, great. Update later today.
Hi, lots of snail questions.
Go for it.
Did you guys do the airflow testing on the old setup with the critter keepers by chance? Or was it just when they were moved to the butterfly nets?
Just to the butterfly nets, yeah.
Okay.
Yeah, because we were trying to figure out why the humidity was not fluctuating.
Gotcha. And I'm just curious what your temperature range is. Like what you said, like 7-degree difference between the max and min.
Mm-hmm.
What do you guys consider ideal? Ours is pretty narrow at Woodland Park, but I don't know where those numbers came from, so I was just curious to
I believe the
compare.
room is kept at like 75, but obviously it fluctuates in, is that right, Jamie? Okay, it fluctuates within the tanks themselves. So that 7 degree Fahrenheit range kind of sits above that 75. Like sometimes it gets to 80, sometimes it's like 73, but it really didn't go too far extremely beyond that.
Okay. And I also, here, is there anyone else? I'm sorry. Oh, sorry, yeah, go ahead.
Sorry, I don't know much about this, but will you mind explaining what the wet-dry cycle is for the snail?
Mm-hmm. So when they get serviced by a keeper, they add a certain amount of water, so it's really, really wet. They don't get touched for 3 days, so it kind of starts to dry out, and so it's not as a constant level of humidity the entire time, which seems to be what the snails want. And so then the keeper will come in again, make it, give it a certain amount of water again, get it wet, and then it'll be able to evaporate to a certain amount of dryness. Yeah, which is what we were hoping to restore.
All right, if you have any other questions, catch them after.
Awesome, thank you.